Welcome to video lecture on Unit 2 System Architecture and Memory Management. In first unit, we seen that the instruction set of 80386 and some basic features of 80386. So as we know that the many of architectural features of the 80386 are used only by the system programmers. So in this chapter, I'm going to present an overview of these aspects of the architecture. So the course outcome for this unit 2 is after completion of unit 2, students should able to illustrate basic model, system architecture and memory management of 80386DX microprocessor. So as we know that the system level features of the 80386 architecture includes memory management, that is the 80386 transforms the logical address, that is the address as viewed by the programmers, into the physical address. So how actually the address trans is used and which are the memory management registers are used for the support for the memory management. Then next is a protection, that is that then how actually the multitasking is occurs in 80386. So this is the one of the best features of the 80386. Input output, it is just about the method of addressing IO ports and with respect to the IO operations. Exception and interrupts, so as we already seen that 16 exceptions are occurred or handled by the 80386. It depends on the condition. Then the initialization, so some additional initialization must be performed by the software before all the features of the processor can be utilized. Co-processing and multiprocessing. So 80386 has two level of support for the multiple parallel processing units. So it is specialized interface for very closely coupled processors. It is known as coprocessor. Debugging is the single step debugging support for the single step exception and breakpoint exception. So previous processor also support these features, but in 80386 the principle for the debugging support is the debug register. Then the first point of this chapter is we are going to see the details about the system registers. So the system registers of 80386 includes the register designed for the use by the system programmer fall into these classes, that is the E flags, that is the extended flag, then the memory management register, control registers, debug registers and the test register. So the first we are going to see the E flag registers. So in that E flag register, actually the system flags are used by the system programmers. So system flags are not available to the application programmers. So as we know that the flag register is a 32-bit register named as the extended flags. The flags may be considered in the three groups: status flag, control flags and the system flag. So as we see in the figure, the status flag are your CF, that is the carry flag, then parity flag, auxiliary carry flag, zero flag, SF, that is sign flag, OF, overflow flag. So these are the status flag. These status flags of the E flag registers allow the result of one instruction to influence the later instructions. So mostly the arithmetic instruction uses your overflow flag, sign flag, 0 flag, then F, that is the auxiliary carry flag, then the parity flag and the carry flag. While the control flag is the your DF, that is the direction flag. It is used by either some control string instructions. So the system flags, actually the system flags are the flags it is used by the system programmers. So the system flag of the E flag register control the IO, maskable interrupts, debugging, task switching, and enabling of the virtual 8086 execution in protected multitasking environments. So this is your IF, that is interrupt enable flag. Then this is nested task flag. This is a resume flag. This is your virtual 8086 mode flag. This is the trap flag. So the first is interrupt enable flag. It is at the so when we set the IO flag, it allows the CPU to recognize external maskable interrupts. Once I am going to repeat that. When we set IF flag, it allows a CPU to recognize external maskable interrupts. Okay, so I am saying a maskable interrupts only. So when IF is equal to 1, it just recognize external maskable interrupts. When clearing the IF, disable these interrupts. So when IF is equal to 0, the external maskable interrupts are not come to the microprocessor 8036. If it has no effect on the either exception or non maskable external interrupts. So value of IF is equal to 0 or 1. It does not affect on the maskable interrupts, non maskable external interrupts and the exceptions. Next is a nested task. The processor uses the nested task flag to control the chaining of the interrupted and call the task. So NT influences the operation of IRET instructions. Next is a resume flag. The RF flag is temporarily disables the debug exception so that an instruction can be restarted after the debug exception without immediately causing another debug exception. Next is a trap flag. So when we set the trap flag, the processor goes into the single step mode, that is in a debugging mode. So in this mode, the CPU automatically generates an exception after each instruction, allowing a program to be inspected as it executes each instructions. So single stepping is just one of several debugging feature of the 80386. When we set the virtual 8086 mode flag, the VM flag indicates that the task is executing an 8086 program. Okay. So in next lecture we are going to see some review question on this video lecture. Thank you.